Okay, guys, this video today we're going to be talking about how to find normal probabilities in areas using traditional inverse norm and normcdf commands on the Inspire, but doing that with Desmos. Okay, so I've got a couple examples that I'll run through from my class. In this case, we've got year 10 math students. We have a normal distribution with the mean of 75. That's going to be right here. We know the standard deviation is 8, and so we're going to find some different probabilities. So this will be using, your typical norm CDF on the Inspire or 84, and then we'll do an example with a standard normal curve, which I'm not going to write it here. Actually, I have it written, so let me show you. That'll be a little bit clearer. A standard normal curve that has a mean of 0 and a standard deviation always, and we'll be finding values that produce a certain area. Okay? So let's do the typical norm CDF first. So I've got a normal distribution, mean 75, standard deviation 8. So I'm going to put that in Desmos, create that distribution first. The way we can do that is we can click this plus. We're going to choose inference. Okay, we're going to select a probability distribution, and we're going to choose a normal. And the two parameters that we have to input are the mean and the standard deviation. And just to double check, the mean was 75. So I'll put that in. The standard deviation is 8. And then I'll click create distribution. Okay, so now I've got a nice normal distribution. Desmos kind of graphs it, centers it perfectly. Right, here's the center. Okay, and now I'm going to check this right facing arrow, and this gives me a lot of different options. Okay. The key thing to remember is we can compute two things. We can compute an area given bounds, or we can compute a bound if we have known area. Okay, so we can use this in two different ways. This question, let's just do for, we'll do two. Okay, actually we can do all three of these real quick. So more than 83, right? If I think about that, more than 83, well, I can graph x equals 83. Okay, so I can see that line, so I want to compute this probability, right? What's the area under this curve? And that will compute to a percentage of values that are above 83. Okay, so I'm just going to uncheck this for now. So I want to compute an area. Okay, and if I think visually, more than 83, if I've drawn this correctly, well, I haven't drawn it. Okay, so this is not good, but I can use this. But that would be all this area here. So on Desmos, I'm going to select, I want a region to the right. I want to compute this area, which means I need to input the bound. So the bound that I want to create is 83, right? So here's my area. Again, I can put my vertical line in, so that means that all this area is 0.159, or more specifically 0.1586, so that's my percentage. Okay, so I can either write my answer as a percentage, and actually I got to be a little bit careful. The question was asking how many students, so 0.159, which is as a percentage 15.9, I'm going to multiply that by my total number of students. That's 500, and that gives me 79. Okay, but the key thing here is to get this 15.9%, right? I'm going to make my normal distribution. I'm going to choose a right area in this case. Okay, and if I choose a right area, I have to input this 83. That's my number right here. That will create that area. Okay, if we do a couple more, right, less than 59, then I'm going to compute this area, and then I should multiply that percentage or that decimal by 500. So if you look at this picture, we should be getting 2.3%, which is going to be about 0.023. So again, on Desmos, now I'm going to select a left area, right? The boundary for that area is now 59, right? This says less than 59, so I need to change this inequality so that I've got 59. Again, guys, here's the decimal 0.0227, which is about 0.023, which is 2.3%, right? So if I multiply that 2.3% by my total number, I get the number. And now if we're between two numbers, right? If we're between two numbers, well then I'm going to just select an inner region. And if you notice, I've got two bounds here. So in this question, we want to be between 67 and 91. So again, I want to compute an area. I'll put my left bound as 67, my right bound is 91. There we go. So my total area covering 67 to 91 is 0.8185. Okay, 0.8185 as a percentage. I just did 81.8%. Multiply by 500, you get this 409. Okay, so that's really it for using an inverse norm type command on Desmos. If you want to stick around for normcdf, I'll do that in a second. If not, hope this was useful, and yeah, see you on another video hopefully. Okay, so now I'll switch to normcdf, right? So this is going to answer questions like yeah, we'll do actually example 2, okay? Let me scroll down to where we don't have answers yet. So, oh, sorry, this is the same thing as example 1, okay? I want, that's the problem where I have a known area and I want to find a value that produces that area. So this is a little bit different. This is using the standard normal curve, which if you've learned it, it's a specific type of normal curve where the center is always 0 and the standard deviation is 1. So let's do one that my class was asking about earlier today. Okay, I want two values. I want a number here and I want a number here, and I have these two areas. So I think the first thing I'm going to do is I'm going to try and find this specific number. So if I look at this area, I know that this is 0. I want to find this bound, right, this number that makes this area 0.1293. So if I create a new normal distribution curve, let me just do this, okay? I'm going to make a new one. So the way we do that, we click the plus button, we go to inference, we choose normal distribution. Specifically for the standard normal, it has a mean of 0, a standard deviation of 1. Okay, it'll recenter that. And again, I want basically this picture, I want this area to be 0.1293. Okay, so here's what I'm going to do. I'm going to select bounds. I want an inner bound. And let's see, I want to make this 0. And I want this number. Hold on, guys. Yeah, okay. So I want this area to be, where is it? 0.1293. Okay, so I'm going to put that in 0.1293, and I'm going to try and change this to 0. Yeah, okay. So let me see if I can do it this way. Actually, I can't. Let me pause this video. Oh, okay, I'm not going to pause it. I saw somebody that I know, but yeah, so let's do this a little bit different way, okay? Let me go back to my notes. So we know this total area, right, is 0.2145 plus 0.1293. So let me just put that in, 0.2145 plus 0.1293, okay? Sorry for that earlier thing. I just wasn't thinking clearly. So that is going to be an area of 0.3439. Now I'm going to subtract this from 0.5, okay? So now I've got 0.1561. So basically what I know is that this area here has to be 0.1561. And if I look at, yeah, my picture here, that's what this is, okay? So this is 0.1561. So I'm going to find this value first, okay? So I'm going to put left, compute the bounds, and I know that my area will be 0.1561. Okay, so that's giving me a z of negative 1.011. That's exactly what this is. The only reason this is different is because this is 0.1562. Let me actually see, 0.2145. Do I have a mistake here? Plus 0.2193. Okay, so guys, yeah, let me make this correct. That should be a 3, which means this is 0.1562. Okay, and now I get exactly negative 1.0102, right? Which 0.0102, which is what this is rounded to 3 decimal places. Okay, so this area here, 0.1562, right? That's what I input. You can see in the picture, that's this area here, okay? And the z value, the value right here that produces that area to the left is negative 0.101, negative 0.1010, okay? So now I want to find the area between that and some unknown value, okay? So now I'm going to go inner area. I'm going to make my left bound is going to be negative 0.1010, okay? And I'm going to make this just 0 for now. So that's 0.344. Now I know the area I want is going to be 0.1293. So I'll put an inner area, and I want that to be 0.12. Sorry guys, I want this to be 0. Why is this not working? 1293. 1293. Oh, well, let's just do this. Yeah. So we'll just find this left area. Sorry guys. So I want this area is 0.1562, right? This area is 0.2145. So now I can do inverse norm with this number, and I can find the values. So I want to do, first of all, 0.5 minus this 0.1293, 0.3707. Okay, so that I want the area to the left, and I want it to be I want the area to the left to be 0.37. What do we say here? 0.5 minus 0.12, 0.3707. Jeez. Okay, I know this is really confusing, so I'm getting negative 0.0329. Okay, so what that means, guys, is that let me graph this. X equals, let's just do this. This is kind of cool. We can copy that, and I'm going to let that be X. X equals this. Okay, so what do we know? So we know when X is negative 0.329 repeating, which is basically negative 0.33, right? This area, right? This area is 0.3707. Why is that significant? Well, that means that this area is 0.1293, and so this value right here is going to be negative 0.330, which is what we have here. Okay, so basically to do an inverse norm, what we want to do is we want to compute the bounds, and we're going to put in the area to the left of what we know, right? So we know that we want this X value here that makes all of this area equal to 0.3707. How did we get that was the area? Well, we knew that this total area from 0 to the left is 0.5. If we do 0.5 minus 0.1293, we get 0.3707. So that's what I'm telling the calculator to do, right? Or what I'm telling Desmos to do. And on the calculator, you would just input inverse norm, that area that you want to the left. The reason that we have these parameters is this is the mean and the standard deviation. On Desmos, that's already taken care of because we've put that into the normal distribution generation. Okay, so that's a little bit longer than I would have wanted explanation-wise, but hopefully that helps you use Desmos to find areas that you want. Okay, see you guys on the next video.